Okay, in this training, we're going to cover how to estimate the height of objects using the shade patterns that they cast. It's similar to a sundial where you're lining up the shade pattern with the hour that the image was taken. You can see there are different shade patterns depending on what image you're looking at because of the date that the image was taken. So here in Google Earth, it's telling us that this image was taken on April 5th. I can also try a different image. So this is Nearmap, and their imagery was taken on August 2nd. So based on that, you can see the shade patterns are very different. Well, Helioscope can model the shade for every hour of the year. So using the shade patterns in Helioscope like a sundial, we can reverse out all we need to know to model the shade accurately. So first, I'm going to draw a keep out. I'm just going to give it an arbitrary height, 50 feet. And the default shade pattern you see here is the winter solstice from 10 to 2. But I only care about an instantaneous measurement. So I'm going to do exactly 11 o'clock. And that's the 11 o'clock shade pattern on the winter solstice. But we remember that this is April 5th. So I just need to update the date to April 5th. And that'll show me the 11 o'clock shade pattern on that date. And just using the sort of sundial technique, we can see that we're going to need to move the time up so that the shade pattern lines up. And here we can see that our shade pattern is too short. So all I need to do is increase the height of my object until it lines up with the shade pattern that's in the underlying image. Now we have a pretty good estimate on the height of this object. And we can do the same thing with Nearmap's imagery. So Nearmap was taken on a different day, so we need to go to see what date that was taken. And we can jump over here and estimate the height of this object using the same technique, but using August 2nd instead of April. We can see the shade pattern is adjusted here. I can move the shade time to be more representative of this image. This looks like it was the afternoon, and that lines up pretty well. Maybe I'll go a little bit higher just to be conservative, make sure I'm over that shape, but otherwise I'm pretty satisfied with the height of this object. The next step is really a lot easier from here on out. All I need to do is adjust my shade patterns to match what I'm seeing in the image. So in this case, I had to decrease the height of this object. Maybe I would want to do a whole tree line for this area. Instead of drawing each individual one, I can draw the whole shape and give it a representative height. If anything, I'm going to be conservative, and that's fine with me. I don't want to have to spend the time to draw all of that. Similarly, I can draw the edge of a roof and estimate the height of that roof. So here I'm just doing a straight line keep out, and I'm going to estimate the height at 10 feet, maybe around 12 feet. And you know what? I'm actually not really satisfied the way I drew that, so I'm actually going to try it one more time on this roof. Just draw that out here, double click, and we'll try the height here. It looks like it's a little bit shorter, maybe 10, somewhere between 10 and 12 feet. So I'm going to go with the lower end of that. I'm going to try 10 feet, just so that I know I'm being conservative. And so I'm going to draw this roof just like we would in any standard helioscope design. Just quickly sketch out where that roof is, double click, choose a module, and set the azimuth. So now that I have my roof defined, I just give it a height. This is from the lowest part of the roof. I'm going to say 10 feet from the lowest part. So now I have the roof here, and this actually really helps me with this other tree here. So I can estimate the size of this tree based on the shade pattern it casts on the roof we just defined. So it all works together. So here I'm going to hide the modules, and I'm going to increase the height of this until my shade pattern matches. So you can see it's over. I'm always going to go on the conservative side. If I uncheck this box, I can leave the modules in the shade. And from this point out, I can do all the sort of shade modeling that Helioscope enables. So I can calculate the hourly energy loss for each module and set a threshold and remove any modules that exceed my threshold. And I can remove modules individually. If you wanted to model bigger areas, just like this large tree section here, you can do it just like we did with the tree line. So I'm just going to draw the whole area and make sure that this shade pattern, I'm going to go big, and I want to make sure that its shade pattern extends to the farthest reaches that this structure could conceivably be. All right, so now I'm pretty much done. I'm just going to go check my electrical, go out to current project, and simulate this report. So that will run pretty quickly. I can jump into my report and get the shade report that I can submit to rebate authorities. So what they're going to want to see is the total solar resource factor by module that we can see there, as well as the total solar resource factor by field segment. So this gives me a nice report that I can submit using the shade patterns from the image. And that's it. That's how you do shade-based height estimating from remote.